Today we're going to talk about the normal model, normal distributions, and the empirical rule. Normal distributions. Normal distributions are described by special curves that are symmetric, unimodal, and bell-shaped. This is the bell-shaped curve. At the center of the curve is your mean, which is denoted with mu. At the inflection points on your bell curve, you have one standard deviation to the right and one standard deviation to the left of the mean. That's how far the data deviates from the mean. Then you have two standard deviations to the right and two standard deviations to the left from the mean, and three standard deviations from the mean to the right and three standard deviations from the mean to the left. Normal distributions. The only information you need to work with a normal distribution are the mean and the standard deviation of that distribution. And that will be within parentheses, and we denote the mean with mu and standard deviation with sigma. The notation you will see for the normal model is a capital N, and then within the parentheses is the standard deviation and the mean, denoted with mu and sigma. For example, N and then 1,000 and 100 would be the normal model with a mean of 1,000 and standard deviation of 100. Normal distributions are used to model many real-world variables like IQ scores, heights of women, weights of Angus steer, and other things that occur naturally. When dealing with normal distributions, we have the empirical rule. It's denoted with 68, 95, and 99.7. And a lot of times you'll see that as the rule. Those are percentages. With the empirical rule, it can only be applied when the distribution of data values can be reasonably well described by a normal curve. If this holds true, then the following holds true. 1. Approximately 68% of the observations are within one standard deviation of the mean. Second, approximately 95% of the observations are within two standard deviations of the mean. And third, approximately 99.7% of the observations are within three standard deviations of the mean. An observation that falls outside of two standard deviations of the mean is pretty unusual. And an observation that is more than three standard deviations from the mean is rare. These are two things that you need to know from memory. This is the bell curve, and this shows you the percentage between the standard deviations. Our bell curve in the center is always the mean. 50% of our data values are to the right, and 50% of our data values are to the left. Within one standard deviation, this purple section, 68% of our data values fall. Within two standard deviations from here to here, 95% of our data fall. And within three standard deviations, 99.7% of our data fall.